Hello everyone, welcome to the channel of Algocamp. So now on this particular channel, we are actually releasing a series on data structures and algorithms where we are going to talk about some of the most important data structures and algorithmic topics which are extremely important for your upcoming software engineering interviews. Apart from that, these are some of the I would say topics that are very helpful in your day-to-day engineering job as well. We have already released a couple of series around searching, right? And we got a really good response on that. And from here, we are going to put really some awesome content around DSA. In most of these lectures, we will try to ensure that we focus on the intuition building aspect of the things, that how you are able to think about something, what are some of the things that people actually neglect but are going to clear some of the really important fundamentals. We are going to see coding implementation, but trust me, my focus is not going to be on the language delivery aspect of the things, that okay, you have to code this in C++ or Java. A lot of problems we have coded in multiple languages. Maybe some of the problems will be in C++, some will be only in JavaScript. I believe if you are somebody who is preparing for an interview, language in 2025 should not be a constraint, because most of the people can actually use ChatGPT to do language conversions. So my motive here is to make sure that you understand the concept in depth. You actually see how exactly somebody might have thought about the problem when they were carving out the problem, what can be some initial thought process, how you can actually drive yourself towards the solution. I believe these are going to be some really important videos that will be really helpful for your upcoming career. So do let us know what is your feedback. We are going to release a lot of more topics. Do let us know what all topics you want to have first, right? And the feedback is going to be important. Also, in case you are actually thinking to level up, you want to learn things with respect to low-level design, high-level design, overall system design for interviews, or you are somebody who wants to do project development in Spring Boot, you want to learn advanced Spring Boot concepts, or let's say advanced Node.js concepts, then we have a lot of courses, live courses running on algocamp.io. So you can check out the website courses.algocamp.io/learn, and there are a lot of courses that are actually listed. A lot of great discounts are actually going on all the courses as well. Do check them out. For each and every single course, we are going to add you to a dedicated Discord community where you can get your doubts resolved as well. All of the courses, we have made sure that we talk about things from the very beginner to the very advanced level that is going to help you level up in your career as a software engineer. So that being said, let's start the video without any further delay. So this is problem number 386, lexicographical numbers coming from LeetCode, marked as medium. You'll see not too many number of upvotes and not one of the most frequently asked question, but yeah, it's a very decent question to understand the concepts of recursion, right? What the problem says is that you have been given a number n and you need to return all the numbers in the range 1 to n. So let's say you are given n as 10. So you need to return all the numbers from 1 to 10 sorted in lexicographical order. Sorted means arranged in lexicographical order. Now, what is a lexicographical order? Lexicographical order is a dictionary order. Dictionary order, if you remember, then A comes, then AB comes, then AC comes, and so on. Like, or you can say A, then double A, then AB, then AC, then AD, so on, right? That's a lexicographical order or the dictionary order. You can see lexical order is the dictionary order also, right? So you have to actually print the numbers in dictionary order, right? For example, let's say you have the numbers like this. That is, you have to print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. These are the numbers and you want to rearrange them in lexicographical order, right? Now assume it to be like this. Assume it to be like this. That 1 is A, sorry, 2 is B, 3 is C, and so on. Assume it like this because we are used to look at dictionaries with A, B, C and alphabets more. Now just think about it. If 1 is A, what is 1, or let's make 0 as A and make 1 as B, 2 as C. Similarly, let's make 3 as D. Okay. Now just think about it. If 1 is 0, if 1 is A, what is 1? Sorry, my bad. 1 is B, 2 is C, 3 is D, 4 is E, and so on. What is 1 0? Can I say 1 0 means BA, right? 1 0 means BA. What is 1 1? 1 1 is, let's say, BB, right? And so on. So you have to imagine these numbers in the form of, let's say, alphabet somehow, which are arranged in your corresponding dictionary. Okay. Now, if you will arrange this dictionary, can I say B comes, then after B, will C come or BA will come? Of course, BA will come. Then BC will come. BD will come. Right? Then BE will be coming, and so on. And after all of this, then C will come, D will come, E will come, F will come, G will come, and so on. So if you see what is B, B is 1. What is BA? BA is 1 0. And this should be a BB also. Then what is BB? 1 1, 1 2, 1 3, 1 4. Then 1 5 will come, and so on. Then after that C comes up, that is 2, then 3, then 4, then 5, 6, and so on. This is called as the dictionary order. That's why for 1 to 13 you get 1, then 10, 11, 12, 13, and then 2, 3, 4, 5, 6, 7, 8, 9. Because you have to look at it in the form of a dictionary, right? That's the main agenda of the corresponding problem, right? Now, whatever are the inbuilt sort functions, so sorting can be done by a bunch of inbuilt functions. If you don't know already about it, we will discuss about it later. A bunch of sorting functions do exist, but they do not directly sort the data in lexicographical order or arrange the data in lexicographical order. They might help you to do it in increasing, decreasing, or some custom order, but not by default as lexicographical order, right? Just one fun fact, not about Java, but for a language like JavaScript, it's pretty different than Java. So in JavaScript, if you actually sort the data, for example, let's say if you get the same data here in a JavaScript array and you do arr.sort, can you see, oh my bad, let's give it 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Okay, let's say this is the array and you sort this array. Then JavaScript is one of those exceptional languages in which when you sort the data, by default it doesn't sort the data in increasing order or decreasing order, but it sorts the data in lexicographical order. So if I have to solve this question, let's say in JavaScript, it's a one-liner problem. Like I can just create this whole array from 1 to n and then just sort it. But in most of the other languages, that's not the case. You have to manually write a logic to actually rearrange the data in lexicographical order. And you can also see that you have not been given the by default array. You have just been given the number n. So if you will go with this kind of an approach where you first construct the array and then do all of the stuff, it might be too much. That means there must be a more elegant way to actually solve this. And I can give you a hint, right? I can give you a hint, at least for our use case, that maybe we can use somehow recursion. Recursion might be useful in this problem. So before we start this particular video, I wanted to actually talk about a very small thing. So this video is going to actually help you understand a real system design interview scenario. We are going to try to mimic a 45 to 60 minute kind of like a round where we are going to solve a problem very similar to how you will solve a similar system design problem in this short time frame. Now, of course, when you work as a software engineer in a company, you have relatively larger amount of time and you can do a lot of more deep dives in even very small level features. But in an interview, the temperament is different, the approach is different, and a similar scenario is actually explained in this particular video. So do consume the content based on that. Also, if you want to see more deep dives and want to understand these topics in a much more deeper level concepts, then do check out the link in the description section below for our System Design 2.0 cohort, where we have talked about a lot more concepts in a lot more detail, which will make you definitely a better software engineer. So let's just start the video. So now, if you carefully see, what we have to actually do is, let's say instead of solving the problem for 1 to n, I will solve a simpler problem that is from 0 to n. Okay, I'll solve it for 0 to n, and then we will be able to just convert it to for 1 to n. So let's say we want to print all the numbers in lexicographical order from 0 to n. How you can visualize lexicographical order is, let's say you start with 0. After 0, 1 will come. But after 1, 2 will not come. After 1, 10 will come. Then after 10, 100 will come. Then after 100, 1000 will come. Okay, let's say the value of n is 1000. Okay, so if you have to print everything from 0 to n in 1000, then 0 comes, then 1 comes, then 10 comes, then 100 comes, then 1000 comes. Now after 100, or let's say the value of n we can take as 1003. Let's take even a custom one. Now after 100, 1000 comes up. Now after 1000, you will try to go to 10,000. But you can see 10,000 is beyond the limit. 10,000 is not within the limit, right? Right. So you will come back. Now from 100, you explored 1000, but you cannot go anywhere further than 1000. So from 1000, now you will go to 1001. Okay. Then from 1001, you will try to go to 10010, but this is not applicable because this is beyond the limit. Then you try to go to 1002. Same thing here, beyond the limit. Then you try to go 1003. Then you try to go 1004. The moment you try to go 1004, you cannot go 1004. Why? Because 1004 is beyond the limit, and so on. You will try this up till 1009. Then you will realize, okay, everything from 1004 to 1009 is beyond the limits. You come back. So everything starting with 100 is done. Now if everything starting with 100 is done, you go back to 10, and now you will try everything starting with 101. Then you will try everything starting with 102, and so on up till 109. Right? So this game actually is going on with what is starting with what. So in this complete subtree, everything starts with 1. Here everything starts with 10. Here everything starts with 100. Here everything starts with 1000. Now if you have explored everything that starts with 100, now you should start exploring everything that starts with 101, everything that starts with 102, and so on, 109. Once you have done that, that means you have explored everything that starts from 10. Start exploring everything that starts from 11. Then start exploring everything that starts from 12, so on up till 19. And similar recursion trees will come up beyond 11 as well. From 11 you go to 110, from 110 you go to 1100, which is beyond the limit. Then you go to 111, and so on, right? This is how you actually print the lexicographical ordering. Because if you see, this is A, B, BA, BAA, B triple A, then this is B double A B, this is B double A C, and so on. This is what? BAB, BAC, and so on. This is what? This is BA, not BC, BA. This is BB, right? This is BC, and so on, right? So that's how the dictionary order works. So for the numbers, the dictionary order works in this way, that you start with, let's say, 0. You explore 1, but before exploring 2, you explore the depth of 1. That is everything that starts with 1. So we go to 10. Now before going to 11, you explore everything that starts with 10. Right? So first of all, you go to 100. Now before you go to 101, you explore everything that starts with 100. Let's say you go to 1000. And from, let's say you cannot go beyond 1000, so you will explore 1001, 1002 up till 1009, right? And then you will come back, and now you have explored everything that starts with 100 within this given range of n. Then now you should start exploring everything that starts from 101, 102 up till 109. Now inside 101 also it will be 1010, 1011 and so on up till 1019. And you keep on exploring this till the time you explore everything under 10. Then you explore 11, everything that starts with 11. So 110, 111, 112 up till 119. Then similar structures below them will exist. And once you are done with that, then you will explore 12 and so on up till 19. Now after exploring everything up till 19, you are done with everything that starts with 1. Now you can start with everything that starts with 2. So this will be 20, 200, 2000 and so on. This is the actual lexicographical ordering, right? Now it's a pretty tricky question, because if you have not ever seen the visualization of lexicographical ordering like this, you might get confused that how exactly we can build the ordering. But now if you have this kind of a tree in mind, then you can carefully see what's happening. From 0 you go to 1, you can go to 2, you can go to 3 up till 9. Okay, from 0 you can go everywhere. But when you are exploring 1, all of these have to wait. It's like when you are calling Fibonacci of f of n minus 1, f of n minus 2 has to wait by the time we explore n minus 1. Similarly, when we are exploring 1, all of this has to wait. So we can make this 1 go in a recursive call. And once we come back, then we go on a recursive call of 2. Then we come back, we go on a recursive call of 3. Now from 1, you can explore 10, 11, 12, so on and so forth up till 19. Right. From 2 also 20, 21, so on and so forth up till 29 and so on. From 10 you can explore 100, 101, 102 up till 109. From 100 you can explore 100 and 1,000, 1,001, 1,002 up till 1,009 and so on. So if you carefully see, from any number n or from any number I, you can make a call to 10 into I plus 0, 10 into I plus 1, 10 into I plus 2, so on, 10 into I plus 9. See, 1 into 10 plus 0, 1 into 10 plus 1, 1 into 10 plus 2, so on and so forth, 1 into 10 plus 9. 10 into 10 plus 0, 10 into 10 plus 1, 10 into 10 plus 2, so on and so forth, 10 into 10 plus 9. 2 into 10 plus 0, 2 into 10 plus 1, 2 into 10 plus 2 up till 2 into 10 plus 9. 100 into 10 plus 0, 100 into 10 plus 1, 100 into 10 plus 2 up till 100 into 10 plus 9. For any number I, you can go to these possible numbers. So let's say if there is a function f of I, or we should keep two parameters n, f of I comma n, and let's say this function prints all the numbers in range I to n in lexico order. Then our main function call will be f of 0 to n, because we are solving the problem for 0 to n. And then what you can actually do is you can make a call to f of 10 into I plus k comma n, where k belongs to 0 to 9. Can I say that? In a loop. So actually how this will look like, you'll say k equals to 0, k less than equal to 9, k plus plus, make a call to f of 10 into I plus k comma n, right? That's how this whole definition looks like, right? And from 1, let's say you reach to 10, wherever and whatever number you reach, you can check if the number is less than or equal to n, you can print that number and you can make recursive calls. If the number is greater than n, you return from there and you don't make any recursive calls. Simple base cases, right? For example, let's say you go to 2. Is 2 less than or equal to n? Yes. No problem. You print 2. Then you go to 20. Is 20 less than or equal to n? Let's say n is 1000. Is 20 less than or equal to n? Yes. No problem. Print it. You go to 200. Is 200 less than or equal to n? Yes. Print it. You start recursive call. Is 2000 less than or equal to n? No. You return. Is 2001 equal to n? No. You return. So on. Is 2009 less than or equal to n? No. So everything for 200 is done. You go back. Now from here you go to 21. Is 21, sorry, not 21, 201. Is 201 less than 1000? Yes. But from 201, whatever you will start will not be less than 1000. Then you go to 202 up till 209 and so on. Right. So for any number I, you can go to 10 into I plus 0, 10 into I plus I, 10 into I plus 1, 10 into I plus 2, up till 10 into I plus 9, except this whole rule works except I equals to 0. You can see in 0, you don't go to 10 into 0 plus 0, because if you go to 10 into 0 plus 0, it becomes 0. You will again come to this. It's like from 0 you go to 0, from 0 you go to 0, you go to 0, you go to 0. This will be what? Infinite. We don't want that. So in case if I is equals to 0, you do not make this call. 10 into I plus 0. If I is equals to 0, you do not make this calls. Else, whatever is the number, we don't care. We will make all the 10 calls. These are 10 calls. In case of I equals to 0, you will just make, you will skip this call. So you can say if I equals to 0 and k equals to 0, continue. Don't make this call. Continue. That's it. That's all that you have to do, right? And you will realize the dry run for this is going to be pretty hard. But if you will just realize one simple thing, that from any number I, you can go to 10 into I plus 0, 10 into I plus 1, 10 into I plus 2, and you can combine this inside of a loop. You will get your answer. You will realize this is a pretty simpler problem to actually solve. Let's try to code it and then we'll be able to visualize it better. So again, simpler stuff. I'll say public static void f. I need to pass a number I need to pass a number n. Okay, cool. Now again, you have to return a list of integers. So result is equals to new array list of integers. Okay, cool. Now what you're going to do, if you want to call for f of I comma n, the answer of f of I comma n is going to be for int k equals to 0, k less than equal to 9, k plus plus. You need to make a call to f of 10 into I plus k comma n. N remains as it is. One corner check, if I is 0 and k is 0, then you continue. You don't make a recursive call, you continue. That's it. And here, if the number you are at is less than or equal to n, what will you do? You will add that number in your answer. Instead of printing, let's add that number inside our answer. Else, we will return. If the number is greater than n, then we will return, right? Okay. This looks pretty good. Okay. Let's try to run this code. Let's see what happens. If I call for f of 0 comma n. And then we return result. But of course, before every test case, we should clear the result. If you run the code, okay, you can see we are getting all of the numbers, right? Everything from 1 to 9 we are getting. It's just that we are getting one extra number. We are getting one extra number, 0. We don't want 0 in our answer. So you can say if I is not equal to 0, then only we will add it. Otherwise, 0 is just going to be used for preparing our answer. If I run the code, looks good. And here we go. See, whatever I said, that's what I wrote. I said if you want to get an answer of f of I comma n, Just go to 10 into I plus 0, 10 into I plus 1, 10 into I plus 2, up till 10 into I plus 9. In case I is 0, please don't go to 10 into 0 plus 0. That's what I wrote. And then before we explore any numbers recursion, we check where can we print this number or not, or should we even explore the recursion or not. So if the number is within the range of n and the number is not equal to 0, then we add it in our answer I. Otherwise, we return. For example, if n is 1000 and we reach somehow 1001, then there is no point of exploring the recursion of 1001. Like there is no point of doing 1001 into 10 plus 0, 1001 into 10 plus 1, 1001 into 10 plus 2. All of this is actually not required. And that's how you can actually solve this problem. So I hope the overall coding implementation through recursion for this problem is clear to everyone.